Introduction to three-phase system. Three-phase system is the most commonly used in power transmission and distribution around the globe. On this presentation, we will discuss the advantages of three-phase over single-phase system in distribution and industrial settings. We will look at the reasons why three-phase systems is still dominant form of transmission and distribution method over the DC or direct current or even single-phase system. On this presentation, we will also analyze the polarity of alternating currents, AC, and its behavior using simple spreadsheet software to understand the additive and subtractive characteristics in AC circuits. In transmission and distribution, a three-phase system can transmit more power compared to a single-phase system. Higher efficiency is the main advantage of three-phase system. Three-phase operated devices and appliances are more efficient than single-phase operated machines. The three-phase motors are more robust and physically smaller compared to single-phase equivalent due to the starting winding and the centrifugal switches used to start the motor. Motors with 10 horsepower and above are normally three-phase due to its practically compared to single-phase that needs starting capacitor, starting windings and centrifugal switch that makes it needs more maintenance compared to three-phase equivalent. Cost effectiveness is another advantage. Three-phase machines are less costly and more efficient. Constant power delivery of the three-phase system, especially in industrial and commercial loads, are important. The power delivered by a three-phase system is relatively constant at all times. Less conducting material is the main reason for the transmission and distribution lines to favor the three-phase system. For a given volt-amperes and voltage ratings, three-phase supply requires less copper or conducting material than single-phase systems. The three conductors of three-phase system can transmit the same amount of power needed for 6 conductors for single-phase in comparison. This is a comparison of single-phase 13.8 kV distribution line over three-phase 13.8 kV distribution network. The limitations of single-phase line is obvious, as three-phase transformer cannot be accommodated unless open delta connection or using two single-phase 8 kV primary rating connected in open V or delta connection. To emphasize the advantage of three-phase over single-phase, the two connections shown of two-wire medium voltage distribution line is connected to two different sources. The first line is connected to three-phase Y-connected source, on line A and B respectively. The second line is connected to single-phase source, which will only single-phase transformer can be connected to this distribution line. The first configuration, although with only two wires, it is possible to install three-phase system using two single-phase transformers and connected in open delta. The capacity rating of this network is 57.7% of closed delta equivalent of the transformers. The figure shown is an open delta connection of two 10 kVA. The apparent power capacity of this connection is 17.32 kVA, considering the 10 kVA rating of each transformers. Noticing the two primary wire sources used, the red and the yellow leads are the phase conductors which are connected to the H1s of the transformers, while the H2s are connected to earth. Therefore, the primary voltage of this system is the line-to-line system voltage divided by square root of 3 of the source substation. This displays the flexibility of three-phase system over the single-phase counterpart. With additional 1 conductor, the full 3-phase system voltage can now be utilized, and therefore the apparent power will be 30 kVA if each transformer is rated 10 kVA. This justified the limited rating of Open Delta with 17.7 kVA. With just 1 additional conductor, the extra of 12 kVA was achieved. The advantage of using 3 single-phase transformer connecting in this fashion is that in case there is failure of 1 transformer, the open bank connection can be used as shown in the previous image. On this next few slides, we will look closer on the behavior of 3-phase alternating current polarity. 3-phase system, as we know, are the vectors of current and voltages that is 120 electrical degrees apart. To understand the complex mathematics of alternating current, we will simulate the resultant vectors of the 3-phase system using the spreadsheet software. Using Excel, the need of converting the degrees to radians is needed as it only process angle on this form. The system is 50 Hz with 250 volts amplitude on this example. 50 Hz means that the cycle will repeat 50 times per second. In other parts of the globe, it is 60 Hz. Now on this example, we will vectorially subtract L1 with L2, L2 with L3, and L3 with L1. Please look closely at the peak values of the sine wave. The maximum peak amplitude is 430 volts. This displays and explains the additive or subtractive characteristics of AC transformers. Finally, we will try the vector sum of negative L1 with negative L2, L2 with L3, and L3 and L1. Notice the resultant wave now is back to 250 volts maximum peak values. This exercise shows that AC circuits indeed has polarity and therefore needs to be observed to avoid wrong voltage output as desired. Thank you for your patience. Any question, please email me at 30226025@blackpool.ac.uk.